there are two major equations of wave. Because wave has this sinusoidal waveform, when I mean sinusoidal, I mean it has the shape of a sine curve. It is therefore represented using a sine function. So the formula, the first equation for wave is y equals a sine theta. So a sine angle, a stands for the amplitude of the wave and theta stands for the phase angle. But this is a condensed version. The theta is affected by many things. Sometimes it is affected by omega t. What do I mean by omega t? When you learn circular waves, you were already told that angular velocity is the angle covered divided by the time taken, because it's angular velocity. So if you cross multiply, that's how the theta is replaced with angular velocity times time. But other times when phase difference is involved, the formula now becomes a sine omega t minus kx. What is omega? We already know that one. Angular velocity, t for time, of course. K is a new value you are not familiar with, which is what we call the wave number. It has no unit. Time is in seconds. Angular velocity is radians per second, but wave number is just a number. X, of course, means displacement in the horizontal. The unit is, of course, cm. Good. Now, I normally tell my students, in some textbooks, you will see so many formulas. This is the most crucial among them because this can help you find many others. What do I mean? This omega has a formula, like angular velocity has a formula. Angular velocity alone is 2 pi frequency. K alone is 2 pi divided by wavelength. So if you already know this, you automatically know all the complex formulas that make up the sine wave. Some of you are also waiting to see how this will help because it still looks too big and too vague. So the last formula you should just take note of is that y is equal to a sine. We remove the omega and we put 2 pi f attached to the t, minus, remove the k, you put 2 pi over lambda multiplying x. Now this is the first wave equation. So before we go into the second, let's try and solve a few examples related to the first. I will only give us two important ones that have a lot to teach us within. Okay, good. So what do we have here? The question says a waveform is represented by this kind of equation, and they say that from this equation we should deduce what the amplitude is, the angular velocity, the frequency, the speed of the wave. So how do we do that? Okay, so this was the equation given to us in the question. Now we just have to compare it with the standard one we know. So where you have y, the original formula was a sine. What was here was actually omega t minus kx. So all you have to do is the position where amplitude used to be invariably means that since this is what my a used to be, it means a is just 5 cm without calculations. Simple. Just compare it with the standard equation. So which means it's important that you know what the standard equation was. Second, angular velocity. You can see clearly where our angular velocity is, the one attached to t. If you look here, what's in that position now is 0.8. So which means angular velocity without calculation again is just what? 0.8. But where you have to help yourself is in the units, radians per second. Third, they ask for frequency. Now when you already have known what angular velocity is, you need not look here any longer. Remind yourself that omega was supposed to be 2 pi f, which means if you try making frequency subject to the formula, it will be omega over 2 pi. So that means your omega is already found to be 0.8 divided by 2 pi. So if 2 goes into 0.8, your answer becomes 0.4 over pi. And what's the unit of frequency? hertz. The last but not the least is now for the speed of the wave. I've not given you the second formula for wave, but the second formula says that velocity or speed of wave is simply lambda times frequency. And in that equation I gave to you, you will arrive at something like this. If you do the omega over the k, you will get exactly lambda times frequency. So what that means is that without also solving, this 0.8 divided by this 4 will give me speed directly. So 0.8 divided by 4, which gives me 0.2 meters per second, represents the speed of the wave. Now that's how easy it is. Let's look at the last one, which I believe is tricky, but can still be solved using exactly this simple method. Okay, looking at this second challenge, so we are asked to find exactly the same set of parameters once more. If you observe, 2 pi is outside of the original location where it should be, so we will have to first rewrite it into the standard form. So 2 pi times 5x will give me 10 pi x, and then 2 pi times 3t will give me 6 pi t. Now that's the first way to debunk the challenge. After you've done that, you can now compare it with the usual a sine omega t minus kx. Now observe what happened here. Originally I would have the coefficient, the one attached to t on the left hand side and the one attached to x on the right hand side. But in this question, they wrote that of x first before that of t. So in your own writing, you have to switch the positions here and put kx minus omega t. Because if you don't do it like that way, you will mistakenly connect omega t with the parameters related to x, and then that will be a total fail. So when you observe that x was written before that of t, you have to also change your standard one to become kx minus omega t instead of the usual omega t minus k minus kx. Now it doesn't change anything. The information is still the same, except now it helps you solve better. So moving that, we can clearly see that the amplitude is 2 centimeters, and next is the angular velocity. And we know angular velocity was everything attached to t, so everything here attached to t is 6 pi. So your angular velocity is 6 pi and the unit is radians per second. Third but not the least is the frequency. Remember what I said. Now that you've known what the angular velocity is, just tell yourself angular velocity should be 2 pi f, which means that only f will become omega dividing 2 pi. What is omega? 6 pi. So that becomes 6 pi divided by 2 pi. With pi cancelling itself and 2 dividing 6, your frequency becomes 3 hertz. And then last but not the least is the speed once more. So to find the speed of the wave, I've told you just do omega dividing k. So the omega is 6 pi and the k is 10 pi. So that gives us 3/5 or 0.6 meters per second. So that is where we'll wrap up for today. We'll soon move further into more advanced solvings in this topic.